Here we look at the hydrohalogenation, or the HX addition, to alkynes. Now, this reaction is very similar to another reaction that we've covered, and that's the HX addition to alkenes. In an HX addition to alkynes, such as HBr, we see something very similar to what we saw when we worked with alkenes. With an alkene, this was a Markovnikov addition, where the halogen added to the more substituted carbon, and the hydrogen added to the less substituted carbon. Working with an alkyne, the reaction works in a very similar fashion. Again, the halogen adds to the more substituted carbon and the hydrogen to the less substituted carbon. At this point, though, we still have an alkene present. And so, assuming that we have additional HBr present, the reaction takes place a second time, and we end up with two bromines on that most substituted carbon. All right, how does this reaction work mechanistically? Part of it we're already familiar with. That second half, when we do the second halogenation, is just the HX addition to an alkene. So the piece that's new here is, what about the addition to the alkyne? And it's believed that this operates under the exact same mechanism, that the alkyne attacks the hydrogen and forms this alkene carbocation. Now, the reason I say believed is a carbocation on an alkene like this is not very stable. It's probably more similar in stability to a primary carbocation than the secondary that it looks like. But it is still believed that that's the form for this mechanism. And then Br minus attacks, and we form our product. So again, basically the same reaction, same mechanism as with an alkene. And if we were to look at the mechanism for the second half, that's the mechanism we already know. Alkene attacks HBr, forms the more stable, more substituted carbocation, which Br minus attacks and gives us our final product. So we can look at some additional examples. And we can do these with HBr. We can do them with HCl. Won't really play and make any difference in our reaction. And in each case, again, the result is going to be that we end up with, two of the bromine, or for the bottom two of the chlorine, on that more substituted carbon. For this bottom one, it doesn't matter which carbon because the two carbons are equally substituted. We just know that we will get both halogens on the same carbon.